Linked list. In the previous section, we have studied about an array. Array is nothing but it is a linear collection of data elements in which the elements are stored in consecutive memory locations. While declaring arrays, we have to specify the size of an array in advance, right, which would restrict the number of elements the array can hold, array can store. For example, if we declare an array with size of 10, which means the array can hold up to maximum 10 data elements but not more than that. What if we are not sure about the number of elements in advance? In such scenario, the array data structure is not going to be the efficient option. Moreover, to make efficient use of memory, the elements must be stored only at randomly at any location rather than in consecutive memory locations. So there must be a data structure which removes the restrictions on the maximum number of elements so and so data structure can hold, and the storage condition to make efficient programs. Linked list is a data structure which is going to be the efficient option, which would be that is free from all these mentioned restrictions. So linked list, why? Because the linked list does not store its element in consecutive memory locations, and also the user can add any number of data elements to the list. Unlike an array, linked list does not allow random access of data, because in linked list the elements can be accessed only in a sequential manner. But like an array, insertions and deletions can be done at any point in the list in a constant time. So linked list is nothing but it is also a linear data structure where elements called nodes are stored in a sequence, and each node in the list contains two parts. One is the data field and another one is the link field. For example, this is the node. Here each and every data element will be referred as a node here, and this is the node, and each node will be having two different fields. One is data field and another one is link field. Data field will be holding the actual data element, and link field, or we can call it as linked field or reference field, this link field or reference field will be holding the address of the next node, which means after processing the current node to which node it is supposed to move on to, that address would be specified here in the link field. So any node if you take, there must be by default there should be two fields, one is data field and another one is link field. Data would have the actual data element and link field will have the address of the next node in the sequence. This data field, we can have any number of data fields in a single node. For example, you want to store students record. When it comes to student record, all the student details will be storing like name, registration number, address, contact number, phone number. So for each and every attribute, different fields can be created here. So one data field is to store the name, and another data field is to store the contact number, and one more data field is to store the email ID. Likewise, like we can create as many data fields we wish, but link field must be only one if it is a singly linked list. If it is doubly linked list, only exactly two fields it should have. If it is singly, exactly only one field it should have. Because singly linked list would traverse towards one particular direction, either in a forward direction or a backward direction. This linked list structure allows for efficient insertion and deletion of elements, as the nodes can be easily added or removed without reorganizing the entire structure. When it comes to array, if you want to perform insertion or deletion in the middle, the entire structure must will get reorganized, right? After, if you want to delete so and so node, all other nodes must be shifted towards its one position to its left. You have to reorganize the structure in the array, whereas in the linked list you no need to reorganize this entire structure. And also linked lists are dynamic, meaning that they can grow or shrink in size as needed, and are commonly used in scenarios where a flexible and efficient way to manage collections of data is required. There are several types of linked list. Before we discuss about the linked list, let me tell how to implement a linked list, how to create a node. The node can be created using the following code. Using the structure, create a node in which there are two fields, one is data field and another one is link field, which is the pointer to the next node. So to create a node, this is the syntax. And let's discuss the example, like how the linked list would work in memory, in the memory structure. So as I told, like this is how the structure will be. Each and every data element will be referred as a node. For example, in the list there are 3 data elements, which means there must be 3 nodes. I want to store 3 data elements, so 3 nodes are required. I am creating 3 nodes, and imagine that these are the addresses. First node address is AA, second node address is BB, and third node address is CC. As I discussed before, there are two fields, one is data field and another one is link field. In the data field, we will store the actual data element. First data element is 5, second data element is 10 and third data element is 50. And also here the elements will not be stored in a consecutive memory locations. Randomly, wherever the space is available, we can create a node in which we can store the data elements. So just imagine first address is AA, second address is QQ and third address is DD. These are the empty spaces, so in which I have created a new node, I have stored the new node and I store the data element into it. Now after accessing 5, it is supposed to move on to the node 10. If so, in the next node of the current node, this is my current node, after processing this data element 5, it is supposed to process 10, which means after this node it has to move on to the node QQ, which is stored in the address QQ. So write QQ here, so that after processing this 5, it would check the link field, it will check the address in the link field. Whichever the address is specified here, it will go to so and so address and process the next data element. Since there is QQ here, it would go to the memory location QQ and it will start accessing the next data element, which is 10. And after accessing 10, it has to access 50, which is stored in the memory location DD. So in the current the node, you are supposed to, in the link field of the current node, you have to store the address DD, so that after processing this so and so node, it will move on to the node DD and it will access it. So only 3 data elements I want to store in the list. So like there is no next node after this, because I have stored only 3 data elements in the linked list. So after third list, there is no other element. So in the next field of the last node, we are supposed to store the null value, which means there is no other node, no other data element to process after this. This is how the linked list would work. So like the second node's address would be stored in the link field of the first node, and the third node's address would be stored in the link field of the second node, which means in the previous node's link field, the current node's address can be stored. Where the first node address would be stored, then you have to create one pointer variable which is called start, in which you have to store the address of the first node in the linked list. Always it has to start from the start pointer only. In the start pointer, there is an address AA, which means the first node is stored in the memory address AA. It will go to AA and it will process the data which has been specified in the data field. After processing this file, it will check the link field. Since there is QQ, it will go to the memory location QQ and it will process the data element which has been specified in the data field. After processing this, it will check the link field. In the link field, DD is there, which means it will go to the memory location DD and process so and so node and so and so data element. After processing 15, after accessing it, it would check the next field of it. Since there is null specified here, it would stop till here. This is how linked list would work. Let's see how it works in a memory structure. Imagine this is the memory structure in which there are datas here, and here I have created a start variable, which means the starting point is going to be, the starting node is going to be, you just imagine that all these numbers 1, 2, 3, 4, 5 are the memory locations, memory addresses. Check the start variable. In the start variable, address 2 has been specified, which means the starting node itself is going to be the data element which has been stored in the memory address 2. So it would check here. It will go to the memory location 2 and this is going to be our first node. In the data field, there is AA, and in the next field is nothing but the address field. In the address field, 6 is there, which means after processing this node, it will go to the memory location 6 and it would process this node. After processing the data element BB, it would check the next field. In the next field, the address, the memory location 4 is specified here, which means after processing this node, it would go to 4 here and it will access the data element CC. After accessing the data element CC, it would check the next field. In the next field, 1 has been specified. Next field will be having the address of the next node. So address 1 is specified. So after processing this, it would go to address 1 and process this node. In this node, data element DD is there. After accessing the data element DD, it would check the next field. In the next field, null is the null or -1, which means there is no other node to process. This is how the linked list structure would work. So in the same memory structure, multiple linked list can be created. For instance, I want to create one more linked list, second linked list. Okay, the starting point is, which means the first data element I am going to store in the third memory location and the address 3. So in the start variable, the address of first node would be stored here. So the address of first node is 3, which means first node is stored in first node is created in the memory location 3, and I want to store the data element FF. After accessing this data element, to which node it is supposed to move on to must be specified in the next field. For example, I want to go to 7, which means after processing this data element FF, it would go to the memory location 7 and the new node will be created, and whatever the data element you want to insert or whatever you want to do, the operations you want to perform can be performed. For example, I'm inserting the new data value GG. I'm inserting it in position 7 in the memory address 7. After GG, I want to move on to other available space, the because it would be stored in the random memory locations, right? Since 5 is free, for example, I'm searching for the memory location. Since 5 is free, I'm moving to 5, which means it would go to the memory address 5 and new node is created with the data field and the link field, and you can store new data element which is HH. After third element, I don't want to store any other element, so store null value, which means the list would end here. So in the same structure, in the memory structure, multiple linked list can be created and the element can be accessed only in a sequential manner. Why? Because the data element has been stored in a random memory location, which means wherever the spaces are available, there you are going to create a node and store the data element, and the sequence can be framed, can be created with the help of the next field only. After creating one node, you store data element in the data field, and in the next field you mention the next node's address, so that after processing the current node, it will move on to the next node with the help of the current node's next field. This is how the linked list data structure works. And when it comes to the types of linked list, there are several types of linked list, including singly linked list, doubly linked list and a circular linked list. Singly linked list means it would traverse towards one particular direction, either forward direction or backward direction, which means there would be one data field and only one link field will be there. When it comes to doubly linked list, it would traverse in both the directions. If so, we need to have two link fields. Why? Because to traverse in a forward direction, this would work, the next, this is next, link next and link previous. So link next will be having the address of the next node and link previous would be having the address of the previous node. So in linked list, in doubly linked list, each node will have two address fields and one data field. You can have any number of data fields, but yeah, one for storing the data, one space would be given, space would be created, and two address fields would be there, one to store the address of the next node and another one to store the address of the previous node. When it comes to circular linked list, it would, like, the last node would be connected with the first node, so that the circular structure can be created. While discussing the circular linked list, you would understand it in a better way. So next type is circular linked list. Under circular linked list, again there are two different types. One is circular singly linked list and circular doubly linked list. Each and every type and its operations would be discussed in detail in different sections in the upcoming videos. And choosing between a linked list, in the previous section we have already discussed an array data structure, that is also going to be the linear data structure. So choosing between a linked list and an array depends on the specific requirements and constraints of the applications of the constraint of the problem. So here are some reasons to use a linked list instead of an array. The very first reason is dynamic size. In a linked list, the linked list can grow and shrink dynamically as elements are added or removed without the need to specify an initial size in the linked list. When it comes to an array, it requires a predefined size or resizing, which can be costly in terms of time and also memory when the size changes frequently. The second reason is efficient insertion and deletion. In linked list, insertions and deletions can be done efficiently with the big O of one time complexity, provided the position is known, as it involves updating the pointers. When it comes to an array, inserting or deleting elements requires shifting elements, right? If you want to perform insertion, you have to shift one position to its right. If it is deletion, you have to shift one position to its left, which can be expensive with the big O of n time complexity, where n is the number of elements. And the third reason is memory utilization. In linked list, it uses memory only for the elements present and the pointers to the next. This can be more memory efficient if the size of data structure changes frequently. When it comes to an array, it allocates a fixed amount of memory initially, which can lead to wasted space if not fully utilized, or it requires resizing if the array grows beyond its initial capacity. So these are the reasons why we should prefer linked list over an array. Thank you.